Alright, I just want to reiterate something about this number 2 example here. We first used that positive slope to get points, and then we used, well, this is positive too once you do the division, but we used this negative over that negative to get another point on our line. Now, this does really not fit the definition of slope, or at least how we want to think about it. Remember, here it tells us, let's see, it's calculated by this and tells us how the output variable changes one of those three for each additional input. So for each additional input here, if I were to draw this line, it looks like this. And so for each additional input, that 5/2 doesn't tell us much. It tells us how it changes for every 2, but we want to change for every additional or every 1 input. So what could we do? Well, we could actually do the division. If you take 5 divided by 2, that will give you 2.5. And so if you think of that as over 1, we can think now our slope as being 2.5. And if we start with our original, here's what this slope of 2.5 is saying. Our output variable is changing 2.5 for every change of 1 in the input. So in other words, if I were to change the output by 2.5 as this guy increases, positive 1 increases by 1, let's add that and add that, that would get me another point on the line. So that would be add 1 to the input and add 2.5 to the output, so 9.5. Does that give me a point on my line? Let's look at 5 and then 9.5. Yeah, I'm sorry I didn't use my ruler, but yeah, 9, 5.5 would be another point. I'm sorry, 5, 9.5. 5, 9.5 is that point. So this is the way we want to look at it here, a single value. So we could say this, that the p-value increases by 2.5 for each additional t value along this axis. So that's a really good way to think of slope.